code. So with that, I'm just going to stop there and ask if anybody has any questions related to legislative update or any bills that are pending, where they might be or what might be happening with them. No? Okay. On the regulatory side, I think everybody is likely aware that the Department of Energy Resources has released their stretch code and their municipal opt-in code, or I should say the drafts of their stretch code and their municipal opt-in code. If anybody hasn't seen it, just open your chat. I've put a link in there that will bring you to the state website where you can view the two codes. There is a end date of August 8th. That is the date by which they will close the public comments period. They are having 2 in-person public hearing sessions and then a virtual session on, the virtual session will be on August 8th. The deadline to submit comments is, excuse me, the deadline to submit the comments is August 12th. Pardon me. In terms of whether AIA Massachusetts is going to do what we did, excuse me, for the straw proposal, the Board of AIA Massachusetts has decided not to try to bring everybody together to put a set of comments together to submit. After review of the new stretch code and the municipal opt-in code, and if you go to that link, you'll see that there is actually a summary document, which Megan, Josh, I can put up on the screen if you'd like me to. We could scroll through it if you find that useful. I just need to make me a co-host and then I can put it up. But the board reviewed what has been proposed and looked at it holistically and politically and said what DOER has put out did address a lot of the concerns that have been raised. So for instance, existing buildings is now covered by the stretch code on the residential and commercial side. There is a path outlined in the new stretch and municipal for full electrification of any building. There's also a path to get to net zero with a definition of net zero building. Yes, the building code does still allow for anybody that has a fossil fuel building to continue to use fossil fuel buildings, but or continue to use fossil fuels, but through the renovation portion of what's in both the residential and commercial, it is moving towards a greater level of energy efficiency in the renovation work. And more importantly, it does require that when you do that work, you have to take steps to put in conduit, put in wire for the future electrification of the building. So we looked at all those steps. We looked at the fact that the net zero is pointing to the AIA written net zero appendices that's included in the 2021 IECC, both the residential and commercial appendices. So we took that to be a massive victory, that will become the standard that we use for buildings that are attempting to get to net zero. And then we looked at the political side of the equation, which is simply the fact that we have an administration, the Baker administration, pardon me, whose tenure will come to a conclusion in January. And the concern that we have is that if the Department of Energy Resources does not promulgate their code by December, prior to the new administration coming in, what we know will happen is the same thing that happens when every administration or every new administration comes in, which is they come in January, somewhere around February or March, they will issue an executive order that tells all state boards or any board or commission that promulgates a state regulation to immediately put their regulations on hold, to re-review their regulations and essentially re-justify their regulations. And the long and short is it puts about a 1-year gap from the time the new administration comes in to the time where any new regulations get promulgated. So our concern is, again, if DOER doesn't get the regulations promulgated by December, then we're going to lose a year in trying to get new energy code regulations out there. And that being said, we also know that DOER is very, very unlikely to accept any major changes or any substantive changes to what they've already proposed. And that's simply because if they agree that there should be a big substantive change, they will have to take their entire code, resubmit it to the Baker administration, and go through the internal Baker administration review process. And what we know is if they do that, there will not be enough time for the Baker administration's Department of A&F and the various secretaries to look at the proposed changes to see if they have any effect on any other state agency, and then give approval so that the DOER can then move forward. There just simply isn't enough time left on the clock. Now, we also know that DOER has created a brand new technical advisory committee. And I've attended their first meeting. Their first meeting was somewhere around the end of June. I don't have the exact date on me right now, but I did attend that meeting, and that meeting was attended by the commissioner of DOER and their director of energy efficiency, and they had indicated that the formation of the technical advisory committee was in recognition of the imperative for good energy code policy and the need for clarity in regulatory and language. But more importantly, they noted that they intended to finalize their regulations by the fall of this year so that they could officially promulgate them, meaning they're in use out on the street, by December of this year. Then he also noted that the makeup, or it was made clear that the makeup of the technical advisory committee was encouraging in that its members are not going to focus on policy, but instead are going to focus on the technical feasibility of the proposals themselves. And to that, I was very happy to hear and very happy to see that there were a lot of folks on the technical advisory committee that we've worked with in the past. So for instance, the technical advisory committee is being chaired by Ian Finlayson, who we've been working with for many, many years with the Department of Energy Resources. It also includes DOER's building science specialist, Paul Ormond, who Paul and Ian had done a presentation on the, back when the stretch energy code and municipal opt-in code were still straw proposals, and they presented that to all of our members. The technical advisory committee also includes Green Engineer CEO Chris Schaffner, who hopefully a lot of you know, Passive House policy analyst and former BSA Codes Committee participant Isaac Ellencave, Director of Sustainable Design at BHA and current BSA affiliate director on the board, Jacob Knowles, Department of Fire Services Chief Fire Protection Engineer Jen Hoyt, New Building Institute Director Kim Cheslick, HERS Rater Michael Brown, and Director of Sustainable Design at SMMA, Martine Dion. So looking at all that, what we came to the conclusion, or what the board came to the conclusion, was that there is a great technical advisory committee, and there's a lot more members than just those members that I mentioned. If anybody's interested, I can certainly send a list to Megan and Josh of all of the members on the technical advisory committee. But we looked at the membership of the technical advisory committee. It is very much heavy with engineers and technical experts. We know that the technical advisory committee is now going to be the sounding board and the board by which any proposal to modify the energy code will run through that technical advisory committee, and that they will be reviewing it from the lens of technical feasibility as opposed to whether this is a good policy or not, because that decision gets made much higher up the food chain by the commissioner of DOER or the secretary of Energy and Environmental Affairs or whoever the governor is. And that what has been proposed meets all of the things that we've been talking about, which is expanding the stretch code to existing buildings, and the municipal opt-in code will also get into existing buildings, that there is a standard to build to as it relates to net zero, that there is a path in there or multiple paths to electrify buildings, and it does still allow for fossil fuel use. While I know folks on the left will argue that fossil fuels should be banned, the reality is the building code does not pick winners or losers as it relates to fuel sources. It simply tells you, here's the health, safety, welfare standard you must meet, and you are allowed to pick based on the project you are working on and what makes the most sense for your owner to do. And as we all know, there is still quite a few buildings out there that still use fossil fuels, and the cost to switch from fossil fuels to full electrification is still very much a barrier for lots of people. So for all of those reasons, we looked at it, the board, I should say, looked at it and said, this is a good starting point. This is a good next edition of the Stretch Energy Code and a very good starting point for the municipal opt-in code. Therefore, the decision was made that AIA Massachusetts will not try to be a ringleader to bring all the 3 chapters together to figure out how to submit comments to DOER on behalf of AIA, but instead is encouraging all members to take a look at what DOER has proposed so you can become familiar with it. And if you have suggestions, feel free to submit your comments to the Department of Energy Resources, where they will look at them and make decisions accordingly. Again, keep in mind that major substantive changes are very unlikely to be addressed in this version of the code. Also keep in mind that the state is required to adopt the latest version of the IECC within 1 year of its promulgation. And so what that really means is that the Department of Energy Resources, and more specifically the Technical Advisory Committee, at the beginning of 2023 is when ICC will likely promulgate the 2024 IECC. So therein lies the kickoff of DOER and the Technical Advisory Committee starting to review the next version of the Energy Code and the next versions of a Stretch Energy Code and a Municipal Opt-in Code based on the 2024 set of documents. And once that process begins, we will once again have plenty of opportunities to start to weigh in on major changes that we might like to see. With that, I do see that Tarek Lescu is here. So Tarek, I think, as everybody knows, is now the new architect representative to the BBRS. She's been serving on the board for 2 or 3 meetings now. There was a meeting last week that had been canceled. So the next meeting of the BBRS is scheduled for July 28th. They have been doubling up on their meetings to try to get themselves back on track to try to have the 10th edition promulgated by December of this year, to avoid exactly what I mentioned earlier about that loss of a year with the incoming of a new administration. I will say parenthetically that we as an AIA Mass have been meeting with the various lieutenant governor candidates and others in the prospective Healy administration to really talk to them about making sure that if they come in and the 10th edition of the building code has not been promulgated under the Baker administration, that they do what they can to move the 10th edition through their process as soon as possible so that we don't lose another year in working in the 9th edition to get to the 10th edition. But with that, maybe I don't know if Tarek wants to offer any thoughts, but I at least want to, since I mentioned her name, I thought it'd be appropriate at least to give her the opportunity to say something if she has anything to offer, if she's there. I'll take that as a no. And oh, she's not in a place where she can speak right now, so I'm guessing that means she's probably in her car. So with that, I see I'm right at 8:27. So if anybody has any questions, please feel free to ask. And if not, I'll turn it back to Megan and Josh so you can move on to the smoke presentation. Okay.
Thanks, John.
Thank you.
We appreciate it.
No problem.
Were there any questions for John before we move to the smoke control presentation? Okay, hearing none. Thank you all again for being here. I will now, I'd like to present or introduce Arthur Gager from Jensen Hughes. He and Tony Wilkins will be presenting today on incorporating smoke control throughout a project from concept design through certificate of occupancy. As always, if you have questions, you are welcome to put them into the chat and we will filter them at the end of the presentation. You're also, of course, welcome to wait until the end of the presentation and ask questions in person as well. So with that, Arthur, you are welcome to take it away.
Yeah, thanks for just setting up the presentation now. It's PowerPoint, so I think we're going to probably request to share a screen. Do you?
Looks like you are sharing, but you're sharing the presentation mode, not the full slideshow mode.
Okay. Can you share your screen? Stop. Or yeah.
I think you can switch it if you go to display settings. There's usually a toggle button.
All right, now you see it.
Looks good.
Awesome. All right, so we'll start with just a brief introduction and an overview of Jensen Hughes, and then we'll get into the technical spot relatively quickly. We're anticipating this presentation to go about a little under 90 minutes to leave some time for questions or comments after. And then those presentations for smoke control, so it's really like the larger type of buildings.
Hey, good morning, everybody. My name is Tony Wilkins. I work with Arthur here at Jensen Hughes. I'm a staff consultant here. I have about a little over 3 years of experience. Most of my areas of focus are smoke control design and special inspection. I mostly work with the smoke control design parts, including FDS and CONTAM modeling, which are stands for Fire Dynamic Simulator. I also specialize in fire alarm design as well.
And then I'm Arthur Gager. I've been with Jensen Hughes for 11 years. I was with the general contractor before then briefly. I worked with Josh actually briefly too. So over that time, I've done a number of different things. A lot more of my focus has started with smoke control system design, and then got more into special inspection and testing. I kind of like those areas because the special inspection and testing is more like the implementation of a system. So it is cool when you work on something in design to then see it come to fruition and see it work. Along with that, I do a lot of code consulting, so general building code, 780 CMR, some accessibility, and with that comes a lot into laboratory design. So I'll give a quick overview of Jensen Hughes for anyone who hasn't heard of Jensen Hughes before. It was two companies. There was Rolf Jensen Associates and Hughes. About 6 or 7 years ago, they merged to create one, and they've been acquiring more adjacent companies. The form of Jensen Hughes was advancing the science of safety. So the firm has about 1,400 employees throughout the world, and with that group of people, there's they do fire building safety, risk hazard analysis, emergency management, security, and forensics. With those 1,400 employees throughout the world, those people have done work in every continent and have an office in really every major city within the United States. Locally, we have a Boston/Westboro office. I actually work out of our Boston office in 33 Arch Street, which is a satellite to our Westboro office. Then we have a Providence office, a Plainsville office, and 3 offices around New York City. The scope of services we offer, we do a lot of accessibility and building code consulting. Then we start to get into some more unique things such as emergency action plans, fire protection system designs and commissioning. So that would include fire alarm, fire sprinkler, and smoke control. Then we do fire, smoke, and egress modeling. A lot of work with hazardous materials, as that is, very, very big in the Boston, really the Massachusetts area right now, whether that is laboratories or manufacturing. Then we do a good amount of security and forensic work also. So that's all I have for Jensen Hughes. If you have any questions, you can follow up with Tony or I about what we do or kind of scopes of services. But now we'll get into the overall agenda of this presentation. So with this presentation, we're starting with the applicable codes and standards. Really, I think it's important because that sets the basics and the groundwork to every project, at least for our involvement usually. Then we'll talk about early phases of smoke control incorporation, and Tony will talk about those two sections. I will then talk about the smoke control during design, and that's really kind of like this schematic through construction documents phase. And then lastly, we'll talk about smoke control during construction, and that's how it's incorporated through kind of from permit to a C of O and occupancy. We definitely know a lot. Smoke control does touch a lot of systems. Being architects, some of that stuff might be super privy to you. Other areas of that might be more of where you're going to oversee or have a more of just like an administrative and not as technical role involved in it. But I think it is helpful for architects to know about this because a lot of times you are kind of ones in charge of the project, whether or not you're the engineer of record or et cetera for the systems. And then we'll touch on the go over any questions that you all might have. So before we get into detail, I just want to go over a basic timeline of smoke control. And this is kind of an idealized or an ideal timeline of a construction project, a very traditional project. All projects do vary based on schedule, and the incorporation of smoke control can definitely vary based on the scope of the project. But an idealized traditional project that goes from programming or BOD/concept phasing, then to schematic design, design development, construction documents, and construction. If we look at that and how smoke control is incorporated in the initial start of a project, that's when you tend to be identifying the building size, use, and project scope. During that phase, you might be figuring out if it's a high rise, if it's a new high rise renovation, etc. Or if it has an atrium, which tend to be the biggest, most common types of smoke control systems. So in that early phase, you kind of figure out the project size, scope, etc. That's when you identify the types of, hopefully start to identify the types of smoke control in the project, and whether you have stair press, elevator press, etc. From there, the project will move into a schematic design phase. And ideally in that phase is when you first figure out the smoke control system approach. So if it is a new high-rise system, you're figuring out, are we going to inject air from the top of the stair or multiple point injection throughout the height of the stair? If it's an atrium, how are you providing makeup air? How are you providing exhaust? And then usually in the end of schematic design, start to identify like a rough order of magnitude for mechanical size. Most smoke control systems are heavily based on mechanical equipment, and whether that is supplying air to pressurize a stair or an elevator, or exhausting a lot of air in an atrium to maintain tenability in that space. In the schematic design phase, you start to get an idea of what size fans you have, so you have an idea of where those can be located, kind of pricing for those, power draw for those, etc. After schematic design, that's when you start to create what's called a smoke control rational analysis. That's a document that really details a smoke control system, its intent, how it works, and is used. It's first off required by code to be provided, but more so, I think it's a single document that will identify a smoke control system. And as we will talk about, smoke control systems involve a lot of different groups and different designers, different engineers, and and even different architects in a single project. So having a single document that outlines these smoke control system or systems is a great tool to use to make sure everyone is on the same page and design kind of around the same stuff. Then throughout design development, that's when you start to finalize the major mechanical and architectural features for smoke control. Where exactly the fans are, exactly, making sure you have sufficient space for those fans, etc. So then the project would move into construction documents. This, Massachusetts requires a third-party review of smoke control rational analysis if it's using the exhaust or pressurization method. So that's typically for atriums and stages that Tony will talk about. But during, that initiating that third-party review early on is beneficial. Ideally, the third-party review is incomplete. They are in concurrence with the rational analysis and there's no significant items. But having that review early, if the third-party reviewer does take objection or does have questions, there still is some time to pivot and kind of incorporate or address their comments. Moving through construction documents, that's usually when you start to coordinate and firm up the electrical and the fire alarm system. Smoke control systems are typically controlled by the fire alarm system as much as possible, and starting to figure out exactly where that's going, the protection of the circuits, and the more the minutia that is involved with smoke control happens in construction documents. Smoke control is a very complex system, so it does require a special inspector. And then again, near the end of construction documents, or sometime we're seeing it more and more early, but identifying who that special inspector is and getting them on board early on in the project also does help. With that, with the end of construction documents, that's when you'll submit your permit documents, which should have the rational analysis, the special inspectors, and is the documents used for building permit approval. Construction is more like the design does start to take a back seat, obviously, and it's more responding to special inspection comments and stuff in the field. So in construction, special inspection is really like the heavy scope for smoke control. With that, there's going to be submittal and shop drawing reviews, duct leakage testing, construction inspections, and functional testing. Near the end of construction, special inspections should be completed. Ideally, it's completed a couple weeks before you are planning for a certificate of occupancy. So that way you have some time if something does come up during special inspection. Also, we see that, we do a lot of special inspection. We kind of see that other times you might start with this schedule that's going to have special inspection being completed 2 or 3 weeks before C of O, which is okay. But then throughout construction, something gets delayed and something happens, and all of a sudden the intent is to complete special inspection like the day of the C of O, which, as we'll talk more about this in particular, that gets very difficult to do and difficult to coordinate and schedule. Following certificate of occupancy is obviously when the design is done, construction's done. But there's things to be aware of for smoke control to make sure building owners and tenants are preparing for. Namely, you have semi-annual and annual testing smoke control systems, which making sure that owners are aware of that is very important. So I just gave kind of an outline of a smoke control system and incorporating it from really the early phases through construction. We're now going to go into a little bit more detail on these items. And if you have questions during the presentation, I don't know I think there's a chat here. We can respond to those, but we'll start to move forward. And then Tony will go into the applicable codes and standards, and then the smoke control system overview.
All right, thanks, Arthur, for that overview of the timeline. So we're going to jump back to the beginning of the timeline. Start with the applicable codes and standards that that are specific to smoke control, and then we're going to dive into the different types of smoke control systems and when they are required. So for everyone's favorite topic, we got the applicable code standards relating to smoke control. Our biggest related ones are the International Building Code, or the Building Code, the Fire Code, and NFPA 92. So in Massachusetts, the Building Code is 780 CMR, and currently we're in the 9th edition, which amends the 2015 International Building Code. Our Fire Code is 521 CMR, which amends the NFPA 1 2015 edition with select provisions of the 2018 edition. And NFPA 92, which is a reference standard in 780 CMR, standard for smoke control systems, and that would be the 2015 edition, as also referenced in 521 CMR. So the Building Code 780 CMR generally outlines what type of systems are going to be required. After we figure out when the system is going to be required, Section 909 of 780 CMR, along with NFPA 1 and NFPA 92, will provide additional details on how this smoke control system is going to be designed and how it's going to be implemented mechanically throughout the project, and how it should function with other systems within the building. The official adoption date of the 10th edition for 780 CMR, as we alluded to earlier in this meeting, is still unknown and being tracked. There are some notable changes in the 2021 IBC regarding smoke control, including atrium requirements. We're not going to dive into those too much today. We do have a presentation that we have given on the 10th edition and the changes from the 2015 and the 2021 codes. So please feel free to reach out if you're curious to see that or listen in on to that presentation as well. So next couple of sections, we're going to start talking about the different types of smoke control systems, and we'll start with what's currently required, or the newer system. So if we're in a newer building, our first item is stair and elevator pressurization. So what is it? It's basically, we take a giant fan and let's see if I get my cursor over here. There we go. We'll take a giant fan, usually injected on the top of a roof, that will put they'll take air and inject it into a shaft, a stair shaft or an elevator shaft. And the main idea for this is that during a fire event, fire and smoke is usually pretty lazy. So it'll move to the area of the path of least resistance. And so shafts, a stair shaft and an elevator shaft, basically act as a giant chimney. So if we have a fire on the second floor, that smoke would normally travel to the path of least resistance. So this stair shaft is going to act as our chimney. That causes a lot of issues. Caused issues back in the day, years ago, because people need to egress through these stairs. These stairs are how people are getting in out of a building during a fire event, and smoke going into our stairwell, or if it's being passed to different floors through our elevators, we're causing issues for our occupants on the higher levels before that they can get out of the building. And stair and elevator pressurization is designed to maintain a positive pressure in your stair or hoistway relative to the building. They're mostly required in high-rise buildings and underground buildings. High-rise buildings are, let's see, lost my cursor here for a moment. There it is. So our high-rise buildings are in Massachusetts, are buildings that are 70 feet above, a walking surface that's 70 feet above the lowest level of fire department access. This is an amendment through 780 CMR and smoke-proof enclosures. That's usually related to stair pressurization. It's another term that we'll hear relating to stair pressurization. Is for stair shafts that extend 75 feet above our lowest level of fire department access. So in Massachusetts, we can technically have a high-rise building without requiring stair pressurization based on that 5-foot difference. And then we also have stair pressurization in underground buildings extending under 30 shaft extending 30 feet under our underground build, below grade, if you will. And then our elevator pressurization is usually used for the omission of elevator lobbies. Usually in our high-rise buildings, elevator lobbies take up a lot of excess space. So architecturally important to you, to everyone on this call, is that sometimes we like an open structure or an open floor plan, our elevators to open up into an open corridor or lobby. And so stair pressure or elevator pressurization allows us to omit the elevator lobbies to have more of to still protect our shaft, but allow us to have more of an open floor plan. And throughout the years, these types of systems have had different historic requirements. So stair pressurization used to have exhausted vestibules that would be in front of the entrance to our stairs on each level. They were designed to create an additional barrier between the floor and the stair, and we would have a specific supply and an exhaust within the vestibule. These were no longer required in the for newer systems. The exhaust was designed at 150% of the supply, and the idea of this was that if smoke was coming close to our stair, that we had a vestibule that could exhaust that additional smoke that's creeping in on our stair. Further research had shown that these vestibules don't add a large beneficial factor, so they have been since removed from the code. However, when we're working on older buildings that still have these systems in place, it is important that these systems are maintained to what they were designed to, so that they still function properly. Additional historical requirements include stair exhaust. There used to be requirements in the third, fourth editions of 780 CMR. So buildings 40, 50 plus years old allowed an exhaust relief vent at the top of our shaft, at the top of our stair shaft, trying to accomplish basically the same thing as to keep smoke outside of our stair. However, it was proven to not be as effective as pressurizing the stair. An example of this is has everyone heard of the Grenfell Tower in England? There was a high-rise building in England, and in 2017, they had a fire up its facade, and it was a tragic fire. But they had one stairwell, and they had a smoke control system within the stair itself, but it was a smoke exhaust system. And part of what it was capable of doing was exhausting a fire out of one flat or one apartment, but it was overwhelmed by the different the fire spread to a second flat, couldn't handle it anymore, and so they tended to fail a little bit more because now we couldn't handle the exhaust of the smoke outside that shaft. There was relief vents as part of requirements for these stair pressurization shafts. Before the use of, we'll hear the term VFD quite a bit, a variable frequency drive. Before those were created, we basically just had a specific amount of a fan blowing a bunch of air. The issue is that if you're blowing in a bunch of air and the pressure is really high, we want people to get into the stair. So if we have too high of a pressure, we can't necessarily push in the door. And these relief vents will bleed off for if our pressure got too high, so we could still allow people into the shaft. And then there's different performance criteria in terms of pressure differentials. With vestibules, we were looking for, we'll hear a term of inches of water. So it'd be 0.1, that's the measurement of pressure used for these systems. So today's requirements are between 0.1 and 0.35 inches of water. Older systems would be had just had a minimum of 0.1. Some had a minimum of 0.15, and those numbers have changed throughout the years based on different research of how much pressure is actually required to keep out smoke. So that was pretty much stair and elevator pressurization. Our other type of system is a smoke exhaust system. And a smoke exhaust system is what it is in the name, is where we're taking smoke outside of a space. It's designed to maintain tenability in a specific area. The term tenability means basically, can you live in the space long enough to egress or walk out of the space? We usually look at tenability in terms of 3 different criteria, as temperature, visibility, and carbon monoxide yield. So fire tends to drop down pretty evenly throughout a space when there is a fire in an enclosed area. And so we'll look at the temperature layer to make sure that people walking on a specific surface aren't going to be exposed to a temperature that's going to be deadly to them, that they're not going to be exposed to toxicity of smoke where it's going to be deadly to them, and provide enough visibility that people can find an exit and walk out of the affected space. So these smoke exhaust systems are usually by mechanical or natural means. Mechanical is usually giant exhaust fans or makeup air fans that will provide our air movement to get smoke out. And then we have natural means, which could be giant exhaust vents on our rooftop, and natural makeup air vents lower to the ground, such as doors or windows open, because we always need to replace the air that we're exhausting to physically move out the smoke. These are typically engineered through CFD models, or computational fluid dynamic models, that include egress modeling. And one of the type of models that we use is the fire dynamics simulator, FDS. Over the years, FDS has come has had many leaps in being able to correctly simulate a fire scenario, to accurately design these types of systems to maintain a tenable environment. And the types of these smoke exhaust systems are usually required for high risk spaces that usually have a lot of people and other factors that make fires especially dangerous. Some of these areas are atria, stages, large assembly, and prisons. So atrium in section 404 of the IBC, any atrium that is 3 or more stories, that connects 3 or more stories, requires a smoke control system. And the main idea is, if we see in the picture in the top right corner, is that usually in an atrium, we have a larger fire load of items, such as a Christmas tree. We have a bunch of furniture down below, maybe a couple of kiosks, and these tend to have like a much larger fire load, and we can't control these fires by sprinklers. And so if it's open up to the higher floor, as shown in that top right picture, somebody can be exposed to those toxic gases and those dangerous temperatures when they wouldn't normally be exposed to that during a regular fire if we were being controlled by sprinklers on just a regular floor. So that's why atriums are usually included in this. And then we have stages that are over 1,000 square feet. There's 2 ways you can. The code allows 2 different ways to accomplish this, and it's to have a ceiling plenum that's 50 feet or above this, 50 feet or above the stage. And this is to give basically a plenum for smoke to gather before people start to have an issue with it. And the reason why 1,000 square feet was determined is that now they'll have much larger set pieces, maybe larger fire loads that are on that kind of stage. And stages are usually in a theater type area. So a large packed amount of people, maybe not so quick for everyone to get out of the space. Again, it's another item to make sure that smoke and that people are not exposed to these smoke and large temperatures, so that they can egress from the space. Large assemblies such as stadiums. When we'll hear the term smoke protected assembly seating. So if we're in an enclosed stadium and we don't have a lot of egress width in our aisles, the IBC and if you're in other jurisdictions that work with the life safety code, require you to have an engineering analysis to make sure that the same items as the atria and the stages is that we're maintaining that tenability. And we also include prisons in here. Prisons also require smoke control systems for a different reason, is that in a prison, if there is a fire, the occupants, the prisoners themselves, are not capable of egressing the space on their own. They're not capable of a term called self-preservation. They require the assistance of some of the officers and the people in charge of the prison. So if there's a fire within the prison and it's a sleeping quarters, we have to make sure that those people can still be protected in those types of events. Some historical requirements specifically to Atrium is that they weren't always designed to maintain a tenable environment. They were designed based on amount of air changes per hour. And this changed around I think the last one was the 6th edition of 780 CMR. And before that, atriums were designed as they called them open wells. And the volume was 600,000 cubic feet. Anything under 600,000 cubic feet required 6 air changes per hour. And anything above that required 4 air changes per hour. These usually resulted in smaller fans and smaller systems. They didn't require much of makeup air. Older buildings will be required to maintain these systems. We'll get into in the next section some of the implications if we have a renovation in these types of spaces for what we have to do with these atrium smoke exhaust systems. In a historic system that's not required anymore is a floor-by-floor ventilation system. These were required up until the 5th edition of 780 CMR, and these were designed to keep smoke from spreading to multiple floors, kind of to keep it located in one central floor. There was 2 ways to design these systems. There's a single floor exhaust shown on the picture's left side, and then we had what was called the sandwich method, which is on the right side. And so the single floor is the floor of incident, or where the fire is located. We'll have an air handling unit switch to an exhaust mode and just exhaust that one space and close off all other supply and exhaust return dampers throughout that building. And they would exhaust smoke from that area to keep it locally within that one floor. The other method was the sandwich method, which is the same. It has the same sequence of operations as the other one. Is that the fire of incident floor will exhaust, but the floors above and below will keep their supplies open from the air handling unit and basically pressurize the floor above and floor below, further keeping that smoke to that one floor. So there's no additional smoke movement throughout the building. These have started to not be required anymore as they are cumbersome. In high-rise buildings, there's a lot of moving parts. Semi-annual tests have buildings haven't been maintained super well with these types of systems. More and more testing has been done to keep these systems as they were designed to, but a lot of dampers break and it requires a lot of replacement But these, if we're in a building that's being renovated with this type of system, we have to maintain its the way it was designed to, because these can cause issues if it doesn't open correctly, such as a supply damper not opening at the correct time, could fuel the fire and make conditions worse. So it's important to keep these functioning to what they were designed to. So a quick summary of these systems and requirements. So we have stair pressurization required in high-rise buildings and underground buildings. Elevator pressurization, the alternative to enclosed elevator lobbies in high-rise or other residential occupancies. Active smoke control or exhaust systems in 3 or taller story atriums. Smoke protected assembly seating, such as like your stadiums or convocation centers. Stages larger than 1,000 square feet or tall, or less than 50 feet of roof height. Underground buildings and older high-rise buildings as that compartment exhaust. So moving on along on that timeline, we're going to start looking at early phase of smoke control incorporation during our concept design. And a couple of items that it's important is to note the common mechanical system arrangements. They're typically dedicated systems. Our stair and elevator pressurization systems are required to be dedicated. So what dedicated means, we have one pressurization fan and its only job is to pressurize the stair during a fire alarm event. These systems are usually, the fans are normally located on the roof, but they can be located anywhere throughout the building. They can be located on the first floor or the 5th floor. The only issue is that they're not located on the roof. They do require a 2-hour enclosure, including all duct work that's involved with the stair pressurization. So will be important to architects is to make sure that the rooftop, especially for newer buildings, and if there's items going in for older buildings, is that we have the correct amount of space on the roof to make sure that these are coordinating space on the roof to make sure that we have enough space for our fans and ductwork. The other item is stair and elevator pressurization usually have what's called, Arthur alluded to this earlier, single or multiple injection systems, meaning as we have a smaller stair on the high-rise level, let's say 8, 9, 10 stories, we can inject air from the top of the stair, and usually we'll make our pressure differential. But as soon as we start getting into 11, 12, 13, all the way up to 40-story buildings, we'll want to inject at every 3rd level as far down as we can, because once you start getting to those, the fans get exponentially larger. 40-story buildings tend to have 40,000 CFM fans, which are not small. And they'll need injections throughout the stair to make sure that we maintain our pressure differentials and door forces. Something that's important to recognize is that does require, the larger that the fan does require ductwork space, and that's usually next to our stair enclosures. So it's just something to keep in mind in terms of floor plan and coordination to make sure that we have the space for that ductwork. Smoke exhaust, like we mentioned before, they're in atria, theaters, large assembly, and prisons. They're usually dedicated exhaust fans, but they don't have to be. Some people, for example, the Seattle airport uses their air handling units to accomplish their smoke control needs. This reduces the amount of fans that they have to use on the throughout the roof, and there's a lot of coordination items that they like to use the air handling units for. It does require more fire smoke dampers throughout their system, but it can be used, and usually our requirements in section 909 will transfer over to our air handling units if they're being used for these items. Makeup air via natural means operable doors and windows, and mechanical air is also used for makeup air as well. If we're using makeup air or mechanical means for our makeup air, usually they can be located on the roof or close to the first floor. The only issue is if we keep a mechanical supply vent on top of the roof, it will have to be ducted down as low as possible, because we don't want to inject supply air at the top of an atrium, because then we'll just blow our smoke and all of our toxic gases around the atrium, and it'll cause issues for our occupants within there trying to egress. And our CFD models and FTS models have shown that makeup air at higher levels tends to cause a lot more issues. It can be done and is usually by a case basis, but if we can find the ways to bring in our makeup air as low as possible, that's our most ideal situation. So early project recognition, we want to ask as many questions early in terms of smoke control. So if it's a new building, or it could be pretty self-explanatory. We consult with your code consultant. For new buildings, we should being able to identify, if it's a high-rise building, identify pretty quickly that a smoke control system, a stair press is going to be needed. If we do ask the questions early, do we want to have elevator lobbies? And if not, we want that open floor plan, then we can incorporate the elevator pressurization quickly. Do we have an atrium that connects 3 or more stories? Are we working at a prison? Those items, when it's a new building, we can identify those pretty early. When we're working with an existing building, this tends to be a little bit different, because with the existing buildings, we have to determine, asking the questions when that building was built, because then we asking your code consultant to dig into to make sure if they do have a system, what was it designed to? Will our renovations impact the existing system? And we go into the next one, architectural renovations. So if we have it, for example, if we have an atrium, creating a new atrium, that one's creating a new atrium within a building. It'll be a new system, and it'll be designed as a new system. But if we're altering the geometry of an existing system or an existing atrium, then CFD analysis and FDS analysis are required to see if that system is still maintaining its original design intent. Because if we're reducing the size of our atrium in half, our fans might not be able to keep up with the same fire load or size to maintain that tenable environment on a higher level. For altering the floor layout, including additional corridors that connect to the atrium, could cause a couple of issues too, because smoke can travel down these areas. And it's just something that we want to keep in mind as we're going through to try to identify early, to make sure that that we can coordinate this early, so we don't run into issues down the road of the models not working, or we're not maintaining tenability, so we can mitigate those issues but still keep the same types of floor plans. Other renovations to look out for: rerouting of ductwork, fan relocation, fire alarm replacement. So smoke control is integrated with our fire alarm. Sometimes the smoke control system can be monitored by the building management system, the BMS. And we've worked on multiple projects where the BMS was replaced or upgraded, and programming within the BMS that was specific towards our stair pressurization, mechanical items had changed and changed the parameters of which our fans were running. One specific one, we were working in a building out in Cambridge. The BMS had our VFD running at 75% of what it was supposed to be. It went through an upgrade. It changed our modeling, and our VFD was running at 100%. And so when we went and did our semi-annual test, we couldn't get in the doors because it was putting in so much air that we couldn't walk. We had to, you basically put our shoulders into it like an NFL linebacker trying to get in there, which causes an issue for anyone who's not able-bodied. And then the addition of other exhaust or supply systems, this tends to be with occupant changes. So if we go from an office to a lab building, and we have lab exhaust that has to run during a fire alarm event, and maybe this lab exhaust is open to our stairs, or can share the same corridor as our stairs, it's always worth consulting with whoever designed the system or your co-consultant who you're working with this project, to make sure that these impacts don't have an impact on the, or these changes don't have an impact on our system's original design intent. I'm going to hand it back over to Arthur and start talking about the next phase.
Thanks a lot, Tony. So Tony went over really like the overview of the systems and how a renovation can impact those different types of smoke control systems. Once that has been determined, you're going to have to work in incorporating either the new system or the renovation into a project design. So I will start discussing that, specifically in incorporating smoke control from schematic design through construction documents. This gets a little difficult, and not to reiterate this too much, but smoke control is not just a single system. It's an integration of a number of building systems, possibly including HVAC, sprinkler, fire alarm, BMS, operable doors and windows, power, etc. So, some of these systems might not be in the purview of an architect, but it's just good to know an overview of what these systems are, and that you might be doing some work that might be impacting a system, then making sure the mechanical engineer of record or electrical engineer of record, or even the fire alarm programmer is aware of what these systems are, so they can incorporate them into the work that they might be doing. So throughout design of a project, we always need to be tracking the building configuration. Building changes can impact smoke control systems. So for instance, for high-rise buildings, if you're modifying the landscape or learning additional information, that we've seen before can change high-rise classification. And we've seen some projects where they start to do sloping and grading, and all of a sudden a building that was not a high-rise or was not requiring smoke control, after some site work is done or roads get kind of planned out, become a high-rise or become a high-rise needing stair press or elevator pressurization. Similarly on that, if you're adding or subtracting floors or turning a penthouse into an occupied story, that can impact the smoke control system also. Then lastly for that, stair pressurization systems, if they use an exit passageway or some other kind of configuration on the first floor to get to the exterior, if that gets changed during the building design, that can also impact your smoke control system. Moving through there, or the overall building shape can impact the smoke control system. And then the atrium configuration or shape also. So if you have an atrium and you start to tinker with where the exhaust is coming from or where the makeup air is coming from, a lot of times that might be like configuring with a security protocol or some exterior facade that can impact the atrium smoke control system. And being cognizant of that is really important. Next, what should happen usually, as you talked about in the design development phase, usually is creating a smoke control rational analysis. It is required by code, But as we said before, it's also a great tool to ensure concurrency between every design group associated with a project. Smoke control rational analyses have to detail the effect of a smoke control system. So that's the weather, climate, or maybe fire conditions that might have on the system. For stair press, that's relatively straightforward, but for like an atrium exhaust system, it gets much more complicated. Also, for atrium exhaust systems, you do have to do a timed egress analysis. And that's verifying how long people take to evacuate or egress from the space of concern. The rational analyses should go over smoke control system interaction, which includes the interaction with other smoke control systems and the general HVAC. Along those lines, there should be a sequence of operations. And that gets really detailed and really should be really thought about for something like a lab building, where you can't just shut off all the exhaust and all the supply during a smoke control event, because lab fume hoods need to generally keep on running all the time to some CFM and some level. The rational analysis will hopefully finalize the equipment and fan sizes, so people can take those fans, start looking at product data sheets, start looking at cut sheets, start looking at electrical distribution for the fans, and then also operable door and windows. Throughout the design phase, that's when you start to detail stuff more and more better. If that's the right term, but you start to detail, you go from rough order of magnitude to specifics. And that could be specifics for fan location and protection and fan sizes, and then really for duct work too. And if you're starting to route stair pressurization ductwork or elevator pressurization ductwork through a building, figuring out how that necessary 2-hour fire resistance rating is provided, and whether they're going to use some kind of product like a fire wrap or fire rated ductwork, or if you might need to do some horizontal gypsum assembly, because all of those create their own specific concerns, which getting ahead of those concerns is very beneficial. Other big mechanical items to consider, as Tony talked about, is where you're injecting air into a stair. If you're going to try and inject at the lowest level, which makes it easiest to balance and will make commissioning easier, but obviously takes up space to get ductwork to the first floor or basement levels of a building, or instead you're going to try to inject from a very high level and just hope that's sufficient to pressurize the stair or hoistway. Looking through that, so I just talked about first, we're looking at detailing the exhaust fans, their location, their protection, the architectural impacts that those might have. Really, we see like once the fans get identified and finalized, that's when you can start to look more at the electrical and fire alarm requirements. Those have less of an architectural impact, so they're generally not as thought about early on. However, ensuring that the generator is sufficiently sized to supply and power the fans and equipment for smoke control, looking at the generator fuel size, and then location, because generator fuel tanks can be a big impact on a building based on possibly secondary containment necessary or fire rated protections of those fuel tanks. There's protection of circuits, smoke or stair press and elevator pressurization systems the circuits, including power and control, must be in 2-hour protection, which if it's a new building, that's relatively straightforward to do. But if you're trying to do some retrofit of a fire alarm system to power or control a stair pressurization system, having to retrofit a 2-hour MI cable through a building with concrete floors can get very, very difficult. You're gonna have to start coring the floors and figuring out the best spot that may have the least amount of impact in it. Then there's a firefighter smoke control panel, which we'll talk about a little bit more in more detail later on. Also in the monitoring and control functions. Something that we should talk about is that smoke control systems must be tested semi-annually, which we'll go into. But smoke control systems also must run a weekly self-test. And that is an automated test that verifies the function of the smoke control system are working correctly, which might not be a big impact. However, these smoke control systems move a lot of air. And having these systems run automatically once a week can be very detrimental to a building owner. Even if it's stair press or elevator press, they're not moving a ton of air. However, in the summer, you're going to be blasting in, these tests usually run for 3 minutes. So in the summer, you'll be putting in 10, 20,000 CFM of air, outside unconditioned air, into each one of your stairs. Similarly, if it's an atrium and you have to run a weekly self-test, atriums are usually the magnitude of 2 to maybe 500,000 CFM of air, unconditioned exterior air. So having this weekly self-test run in the summer or winter is obviously very detrimental to the HVAC of a building. Similarly, it can create security concerns if you have makeup air doors. If your exterior door is open to the exterior, that creates a big security concern. So there are ways to omit the weekly self-test. That does require AHJ review and approval, and does require usually some additional monitoring. So tracking that and getting ahead of that in the design phase is very good. Lastly, there's BMS and seeing what kind of interaction your BMS has with smoke control, because if your BMS has involvement with smoke control, it must be UUKL listed, and that adds a premium to your BMS system. Not to go into too much discussions, but smoke control systems do require a third-party review. And that's smoke control systems incorporating a performance analysis. So that tends to be your atriums and your atriums and your stages tend to be more the ones that are requiring a third-party review. And that is, it's required by 780 CMR. It's an addition to the building code. So making sure that that's done, that the reviewer is brought on board during the design phase. So if they do have concerns or questions, those can be addressed early on. Even Boston does enforce this. Sometimes sometimes this doesn't get picked up till after a permit is issued, which can create concerns because third-party reviewers might have questions or take exception to items in the design, and incorporating those exceptions or those comments after the building's being built is extremely difficult. Near the end of construction documents, that's when you submit design documents to the building inspector for a permit. HJs tend to look for your tier 1 documents, which generally created by your MEP engineer, MEP, FAFP, depending on how it's rolled out. But that should include a fire protection narrative report, obviously HVAC and fire alarm drawings, which will include a sequence of operations. Typically, there's some type of reference to a smoke control panel in these documents. Whether they are explicitly in there or not is somewhat questionable. If it's a very complex system, such as an atrium, we definitely recommend having that smoke control panel in there to make sure it's coordinated and bid correctly. Also, in the design documents, the smoke control rational analysis should be included for the AHJ's review and approval with the project. Moving through that, for a building permit, you should submit the design drawings, the tier 1 construction documents, which we just went over, smoke control rational analysis, and the third-party review, and a statement of special inspections, which we'll talk about briefly. But the statement of special inspection is required by the building code to be submitted with the permit documents. In that 780 CMR section 1704.5 outlines all the special inspections that are required. And this statement of special inspection must be created by the registered design professional in responsible charge for the entity. These are the special inspections that are required by the building code. And you can see there's steel, construction, concrete, masonry, soils, a lot of foundation and primarily structural items. Because of that, and a lot of times not a super detailed review for a statement of special inspections, so stuff like fire resistance penetration in joints and smoke control does get missed from the statement. Unfortunately, because of that, sometimes that gets missed during construction. And special inspection for fire resistance penetrations in joints or smoke control does not get sometimes even identified till later on in the project. As we talk, architects like to make sure that they're aware of these statements of special inspections, because a lot of times structural engineers might submit this, and then the building owner or developer is well aware of not only the schedule and the requirements of it, but the cost of special inspection. It's not a super heavy cost in general compared to a building, but making sure the developer, owner, entity, institution who is creating these buildings is prepared for the cost and the scope and the coordination of special inspection is really good. So make sure that they're aware of that in advance, and it can be incorporated into everything else is extremely beneficial. So at this point, the project's hopefully gone through the permitting process, construction started, and then that's when smoke control and most other things start to shift from the design to, the engineers of record still have some oversight, but more the construction phases. For smoke control, that is primarily smoke control special inspection. 780 CMR requires a commissioning of all smoke control systems to be by a smoke control special inspector. And that applies to all new systems and major system modifications. That second term, major system modifications, is somewhat ambiguous for exactly what would constitute that. And some of that is based on what the AHJs are requiring or requesting. In Boston, we tend to see a lot more desires from this. Usually it's coming from Paul Donga or Rich Baldowski, Aaron Becker, obviously less so now, but those people tend to be asked, or any other fire captains, but those people tend to be asking for the special inspection if you're doing sometimes even a new smoke control panel or a new fire alarm system, that they will require this to be inspected. And that's not only inspection for the work being done, but that the system, not just a fire alarm system, is working and interfacing with smoke control correctly, but also that the system is working the way it's supposed to work. And we'll talk about that with a semi-annual test in a little bit. Special inspection is required to have expertise in smoke control and be approved by the AHJ. The AHJs can reject a smoke control special inspector if they think the person is not not versed or not experienced in the area that they're working on. Smoke control special inspection, it does not take the place of an AHJ. Instead, it's there more for special items that the AHJ might be beyond the area of expertise of an AHJ, or might be very laborsome that AHJs don't really have, don't have the time or bandwidth to support. It's something that requires more review. So these tends to be things that require inspection throughout and not just a test at the end, or like a 30% construction review and a test at the end. Smoke control special inspector is also not the engineer of record, does not need to be the engineer of record. Special inspector can't be the installer for obvious reasons, but the special inspector is there to ensure that the system was built in accordance with the design documents. And if there are questions, the special inspector should raise that to the installer and the design team to hopefully get that good solution. I personally do a lot of special inspections kind of throughout the Northeast. I try to focus on the design documents as much as possible. And there's usually a gap between the design documents and what's being built, just because some stuff might not be detailed in the correct way, or might not be detailed completely in the design documents. I do try and flag that. And if I see something that doesn't comply with code, and even if it isn't the design documents, I will try to flag it to get ahead of stuff. Just to be more of a, ideally be more of a part of the design team than just someone who comes in and looks at construction and then leaves. Hopefully the special inspector can be trying to find solutions to problems and not just identifying areas that are deficient. With smoke control special inspection, they do have to file a smoke control special inspection report. That report is a summation really of the work being done. That will include the duct leakage test reports, smoke control test plan. The test plan is a great document that can ensure concurrency between the construction groups. And that is, you know, the construction manager or general contractor, along with a fire alarm programmer, mechanical contractor. So everyone's aware of what systems will be tested and how they will be tested. During smoke control special inspection, we create daily forms or daily logs that identify usually what I test. So whereas, you know, it's clearly that, hey, we tested these things 2 weeks ago, they worked, and hopefully we don't need to retest. Conversely, if we test them 2 weeks ago, then they don't work this week or this time, it's good just to document that to see what happens. Those daily logs will also show deficiencies, and that's, I think, a great thing to show that rather than just saying them to the CM or the GC who's walking with us. They detail what needs to be done so that can be passed around between the subcontractors and maybe the engineers of record. Smoke control special inspection report at the end is required to be signed and sealed by the engineer of record to ensure that, so the engineer of record signs and seals that testing and the system does function as required by the building design and the engineer of records design for the smoke control system. Usually, once you receive that smoke control report from a special inspector, the AHJ will then schedule their approval test. And the way special inspection goes, the approval test does kind of vary by municipalities. Again, usually Boston and Cambridge are the most stringent. Other municipalities, you know, it does vary a little bit based on their experience with the types of systems. Smoke control systems, first certificate of occupancy, smoke control systems are a life safety system. So something they don't get thought about or you know, notice as much as maybe a traditional fire alarm or sprinkler system or fire pump system, but it is life safety and must be working for certificate of occupancy. The AHJ does review, and they should be testing the systems for their own review. Again, Boston, Cambridge are the most stringent. With the AHJ review and acceptance test, Boston does require a cold smoke test. So that test is required to show the movement of smoke. And it's typically only required for a smoke exhaust system, so an atrium or a stage traditionally. But showing that the system does exhaust smoke, this cold smoke test is not intended to be something that demonstrates the smoke control system's capacity. So it's not intended to show that the system can exhaust a fire, just that smoke is moving out. Some municipalities, I've seen other ones, will also require this at some point. But they're, you know, most of the review is dependent and contingent on that CFD analysis that Tony talked about earlier. And there actually is in language in NFPA 92, which is a standard for smoke control systems that talks about not using smoke to demonstrate the system's capacity. Because obviously cold smoke has different properties than smoke from a fire, which is going to move up much faster. Smoke control special inspection, after that's being done, usually the AHJ will review the smoke control once the fire alarm, generator, and other associated systems have been approved. So if you're planning to, you know, before you submit the smoke control special inspection report, making sure that the fire alarm inspection has been signed off on, and then you give 1 to 2 weeks. In Boston, it's more like 2 weeks from when you submit the report to when the AHJ will come out to do the to do the review of a smoke control system. So again, as we talked about earlier, looking at scheduling, making sure that your NFPA 72 affidavit is done. Then you submit the special inspection report, and then earliest is usually 2 weeks from submission of that report to when BFD would come out to test the system. And that can be difficult in a project where the last couple of weeks gets very condensed. So that's kind of all we're, generally going to talk about during a typical project construction, or a typical design project that goes from programming through construction. Couple quick things we will talk about is the ongoing items, just to ensure that you are all aware of it. Primarily would be routine, semi-annual, and annual testing of existing smoke control systems. So if you have dedicated smoke control equipment, such as dedicated stair pressurization fans or elevator pressurization fans, those must be tested every 6 months. And if you have shared equipment, such as like a exhaust fan for an atrium that also serves HVAC purposes, that must be tested for smoke control annually. Those requirements come from the fire code 527 CMR. Testing is intended to confirm that the system works as required at the time of the installation. So, as Tony had talked about, some of these system design intents have changed. The method for atrium exhaust and stair pressurization has changed over the last 20, 30 years. And the intent is that this testing ensures that it works as it was permitted as installed. So you don't need to retroactively ensure that it works as required by current requirements. With this, the annual testing usually involves multiple contractors. That's gonna be a lead testing agency, so someone who is knowledgeable of the smoke control system and systems and how they work. Fire alarm contractor usually, because the smoke control systems are controlled and monitored generally by fire alarm systems. And I'm sorry, when I said fire alarm contractor, I meant like an ITM firm. Sometimes contractors and installers also have an inspection and testing and maintenance group. Other times they don't. So that's generally the fire alarm ITM for the building. That's like the firm that does the building's quarterly or annual tests. Smoke control semi-annual testing does require an air balancer. Generally requires an electrician or electrical firm that can be there to do the emergency power test. And then there can be, based on what the systems are, such as elevator pressurization, you might need an elevator tech and other technicians. These semi-annual tests should require show the automatic sequence, manual sequences, system priority, standby power. With these, following each test, a report should be provided, because the building owner must be able to provide these reports to the fire department as requested. Generally, the fire department will require these reports if a major renovation is being provided or a fire alarm project is being provided. And then something to talk about, for a building renovation is as a project comes up, and as a, if you're working on a new high or an existing high rise, it's good to ask for these reports ahead of time that you do your work, so you can know. We've seen some stuff where after a construction project is done as a renovation in a building, the smoke control system doesn't work. It might be flagged by the fire department. And if you don't ask for these reports ahead of time, it's very tough, if not impossible, to figure out if the project you might be associated with caused these systems to not work, and therefore you might be liable for them to make them work, or if the system never actually worked in the first place before your project started. If it didn't work, you can incorporate fixing and addressing this project maybe as part of your project, or that it didn't work before your project happened, and therefore hopefully you aren't the ones that should be taking ownership of making the system work. These test reports should be a system overview, applicable code and requirement at the time of the system, the design requirements and intent of the system, so what pressure differentials or CFM was required. These reports should also include the deficiencies, and that is items that need to be addressed. If a if the door opening force is too high, the door doesn't latch, fans don't turn on, etc. And then the property owner or property management company must maintain a copy of these reports and be able to provide them to the local building or fire department upon request. Kind of the last technical slide, which isn't exactly related to smoke control, but something we do want to bring up. 78 CMR 10th edition. And then I'm not sure when the new fire code will be adopted, but the newer codes, so 2018 IBC or 2021 IBC, which will be adopted through 78 CMR 10th edition. And then whenever the fire code becomes updated and adopts a newer edition of NFPA 1, those will require integrated testing of fire protection and life safety systems. And smoke control, as we've kind of talked about, involves a number of systems. So it does have some of the integrated testing feel to it, but it is not specific integrated testing. Integrating testing is somewhat of an owner's rep. And it tests the integration between the various fire protection and life safety systems. And that does require someone who would be an integrated testing agent. Currently, as before, it's not required by code. Cambridge is generally requiring it. It's something that even if it's not required, all the systems should work as intended and as designed. Ensuring that systems do get tested is beneficial, again, not only required by code, but if a building owner or developer is making a building, designing these systems, and we all spend a lot of time designing and building them, if they don't work, it's like kind of like all that work has been done in vain. And then a building owner or manager would be stuck with trying to fix these systems, whether it's smoke control, if special inspections not done right, or integrated testing. They'll be forced to deal with these systems for the life of the building. That having to fix them is much, much more difficult than getting them installed correctly the first time. And that was all we had for the presentation. I plan to leave a couple minutes for questions at the end. So if you want to stop sharing or. So we just stopped sharing. So there's one new chat. Does anybody have any questions about smoke control systems, or have they worked on projects where they've seen either smoke control going well or going not so well? Megan, do you wanna, is Josh still on the call?
Josh had a meeting. He was going to jump back in if his meeting wrapped up a little bit early, but I don't see any questions in the chat. I know everyone's got your information, so if I do have any follow-up questions, can we email you?
Yeah, no, hopefully it was at least educational, I guess.
Yeah, no, thank you. This is great. It was a really thorough presentation. Appreciate talking about all these things. Well, if you don't have any questions, then I think, oh, we have a question. Oh yeah, the presentation did say 521 CMR, but I think was it 527 CMR 1.0?
Yeah, it was, yeah, for the presentation did say 521, which is the Massachusetts Accessibility and Access Board, but 527 CMR is the Massachusetts Fire Code. Comprehensive Fire Safety Code, which adopts NFPA 1. So yeah, that was a typo.
All right, well, if we don't have any other questions, I think we can give everyone let everyone go on with their morning. But thank you again so much. I really appreciate it.
And definitely thanks for inviting us.
Yeah. All right. Well, stay cool, everybody.
Bye.
Thanks again. Bye.